Alright, boys and girls, we're going to talk about area on this video and how area could pop up in your fifth grade classrooms or on a test potentially. So, the first picture that you're looking at here is your mathematics chart or your reference materials. So, again, you would want to get this out if you needed help if it was an area, perimeter, or volume question. So for this one, we're going to focus in on area. So I'm going to circle that part of this chart, which in this case, you're going to be looking at a couple of different things. So you're looking at the area of either a square or a rectangle. And so here you're looking at a couple of different formulas. You're looking at first a square, A equals S times S. And so there you would be thinking about if it were a square, it's going to have equal side lengths. And so that's why you would just take one of the side lengths and then times it by basically the other, which is going to be the same number. So we'll see that here in a second on an example. Or if it were a rectangle, you see A equals L times W, or you could also see A equals BH. The one that I really focus a little bit more on is kind of the more traditional one, especially on this page, which is A equals L times W, or length times width. That's the one where you're taking a length from your shape, whatever. And most of the time it's going to be a rectangle in this case, but it could be a square, but a lot of them are rectangles. But when you're seeing L times W, you're probably more thinking of a rectangle because it has a length and a width. They aren't equal sides. And so you're going to take a length and then you're going to times it by a width. The second formula that I'll circle now is A, or area, equals the base of your rectangle times the height of it, which is basically kind of like saying length times width. It's just a different way to look at it. That formula will probably be used more in middle school when you really start finding areas of different types of shapes, or when you get into geometry later in life. Usually in fifth grade, if you're just going to stick with A equals L times W, or length times width, you should be fine. So let's move on and let's kind of talk about some examples for these. All right, so on this particular one, again, these are just notes that we use in class. And so for this page here, this is referring to our area examples. And so you kind of see the same formulas again. And so here you're looking for the area of a square or a rectangle. We'll start with the one at the top, area of the square. It says A equals S times S. So in this case, you would want to think about what you're dealing with. In this case, you're dealing with a square, and so every side is going to have the side length of 6. And so I could label all of them. I could just label a couple of them. I'm just going to probably label a couple of them just so we can see that we're going to take, the two side lengths in this case, the two that are labeled, and we're just going to multiply them together. And so we're going to take 6 times 6, which is just going to, fall back on math facts. 6 times 6 is 36. And so we're going to have an answer of 36. Now, when you take an area of an object, you're finding what are known as square units. Square units could be anything from square inches to square feet, square yards. And I think, at least when I teach this in class, I try to show what that means so kids get a little bit better feel of it. It's kind of hard to do it on a video, but basically what you're trying to figure out is how many square units would it take to cover that object. And so it's kind of hard for me to do it, especially on this screen and on the size shapes that you see there. But I'm just going to kind of pretend. Now, this is not to scale by any means, but like if I were to draw a square on our square that we're finding an area of, I could pretend that the square that I just drew was a square, and I could just throw out a unit there. I could say it's a square centimeter, which it's probably not, but I'm just pretending. And so if if in my mind, if I'm thinking about what area is the opposite of perimeter, because you're really not thinking about the outside of a shape. You're thinking more about the inside of a shape, or like what, what's being used to cover something. I mean, that's kind of a key word. A lot of times we bring that up in my classes. What's being covered, or what are they using to cover it? So again, think real world. Think of things like carpet, and in your classrooms or in your homes. If you have carpet on your floor, that's covering something. You could think about a poster in your room or a poster in your teacher's classroom. That's covering something. And so when you're thinking of that, kind of back to my picture here, even though it's not the best, but when you're thinking of that, you're thinking, okay, how many of those square units does it take to cover the entire shape? So if I kept drawing my little blue squares, I'm thinking in my mind, how many would it take to cover the entire, shape of a square? Which, again, it's kind of hard to do that on this, particular picture or on the iPad. But if we go back to just what, area is and what you're thinking about, if you know two of the dimensions, in this case, it's a square, so one of the dimensions is 6. All the sides are 6. So I could, instead of going and drawing and counting squares and having to do all that business, I could just simply fall back on the formula. And the formula for a square would be take a side length and times it by another side length. In this case, 6 times 6. So if I'm pretending here, I could say it would take 36 square units to cover that particular shape. Okay, let's move down to the rectangle. It's really the same thought process. It's how many square units does it take to cover that rectangle? And it's different now because I'm now dealing with a rectangle, not a square. So I'm going to shift my formula here to A equals L times W, or length times width. And so in this case, I'm looking at a side length of 9 and a width of 4. So really and truly, this is going to be, again, just a math fact here. 9 times 4, I'm going to get 36 like I got up above, but I'm dealing with a different shape here. I've got 9 as a side length and then 4 as a side length. I just have the same math fact, or the same product, after I multiply. So again, think real world. A lot of times, again, like I said on the perimeter video, they're going to give you something that is, probably in a word problem, where you're thinking about something being covered, something on the inside of a shape, not the outside, not perimeter here, so kind of the opposite. All right, I'm going to use this same picture that we used for perimeter, but now I'm going to go find the area. So out to the side, I'm going to find area. And this, again, is a complex shape. Again, knowing two things, when you're looking for missing sides of a complex shape, especially for area, you're going to have to really slow down a little bit, because this is going to mean a little bit more work. Not a ton, and it kind of depends on the numbers that they give you. If the numbers stay pretty friendly, usually it's not too bad. But you got to really be careful here, because if you try to rush, you're going to simply make a mistake. This is where it gets a little bit difficult, I think, for kids, because when they see area, a lot of times they think length times width. Well, length times width is when you're looking at a rectangle. This is not a rectangle. You can't say side times side. That's for a square. This is not a square. This is a complex shape that, if you look at it carefully, though, maybe we can turn it into a rectangle and a square. So that's going to be really the first thing that we're going to cover. Again, missing sides are important. I'm going to do the same thing I did if you watch the perimeter video. I'm going to start with the missing side here. I'm going to label this bottom side that's missing 8 meters, because in this case, I know it's the same as the top. And then I'm going to go ahead and do this on the other side. I'm going to label this 1 meter in here, because there is one little portion there where we have something missing. But once I do that, I'm going to switch colors here to show, now that I have my missing sides, I'm going to have to split this thing up. So it's almost kind of like I'm going to have to find area twice. And once I find it for two different shapes, I might combine my answers. And we'll kind of talk about that. So when I look at this shape, I actually see a rectangle and a square. And the reason is because right here, I'm going to draw a line. It's not the prettiest line, but right here, if I split the shape up, this outlined shape I know to be a square. And the reason I know that is because the top 3 millimeters and the side 3 millimeters are the same. And so if I look just at that red right there, I definitely see a square. And so I know for that, I could say area for that is going to be 3 times 3 because it's side times side. So that one's done. I could solve that one quickly. That's going to give me 9. Okay, well, that's just that area. I'm going to go back to my blue, though, and I'm going to say, okay, in this area, this is more of a rectangle. And so now I have to think, even though I found missing sides, I'm just looking at my blue rectangle here. And if I just look at my blue rectangle, really the 8, the 8 meters that I found doesn't mean anything. Because when I split it up, now that I have a square and a rectangle, I'm really looking for my length and my width. Well, I know it's not 8 because my 8 was all the way across the bottom. I'm not going all the way across the bottom now. I'm going part of the way across the bottom. I'm going to focus more on the 5 and the 4 because those are truly now my length and width. And so now I'm going to come over and I'm going to say area for this is going to equal 4 times 5. Or 5 times 4, it doesn't matter. And I could say, okay, well, that's going to give me 20. Okay, now I've got to stop and think, well, hey, if I want the area of the entire thing, I've got to look at this as kind of a combination now. I've got a square on one side, I've got a rectangle on the other. If I put those together, I'm going to have to take those two and add them up. Which it's easy because we have friendly numbers here. So 20 plus 9 is going to give me 29. But the thing is, if you want to do this correctly, especially on this one gave you a unit of meters, then I want to write it correctly. In other words, in my mind, I'm thinking again what this really means. This is, when I'm finding area, it's how many square units it takes to cover this shape. And it would take 29 square units, but it's meters. So I'm going to label it 29 meters squared. And that's just, that is a symbol for squared. It's an exponent. Looks like a little 2 that you kind of write up kind of higher and off to the right a little bit. But that's a traditional symbol that you're going to be seeing on some of your answers. So you need to be used to that. That is a squared symbol. So in other words, I'm saying that there's 29 square meters is what it would take to cover this area, which would be pretty large. You have to really understand what a square meter is. You'd have to look kind of if you had like a meter stick, and you can imagine what a square would look like if you put 4 meter sticks together. I mean, that's pretty good size. And so 29 of those is a pretty good size area. So it could be like maybe like a room in a house or something like that. And so it's hard to envision that in your mind when you're seeing it on a screen or on paper. But I think it's important to know what you're doing. I guess my biggest thing is when teachers just teach length times width and you go solve it and you get an answer. That's great. But I think you need to know more to it than that. I think you need to know exactly what you are doing. I mean, this is a skill that you might really use later in life. So that's area. It's kind of just some basic examples of it. But again, when you're going to see these, you're probably going to see them more in a word problem. They're probably going to be a little bit more complex shapes maybe involved with these. Or maybe just a scenario where it's something real world, something out there, that you might see later in life.